Today I'm going to talk to you about biomaterial bribery of the Immune Police. Have you ever wondered what happens when you get a paper cut? Sure, we all notice blood, redness, and a lot of pain. But what most of us don't realize is there's a flurry of activity going on inside. Cells, the building blocks of our body, sense that something is wrong. Now we have different kinds of cells. We have skin cells, bone cells, even hair cells. But today I'm going to talk to you about the police force of the body, the immune cells, that circulate in our blood and keep a constant check on any suspicious activity. Take the paper cut injury, for example. The immune cells rapidly clear any debris and also kill harmful bacteria or viruses that may have entered the open wound. They even signal to other repair cells that come to the site, and together they make new skin. Before you know it, the cut is all but a painful memory, and it's time to move on. Well, at least until the next time you get a paper cut. Now, what happens if we have a larger wound, a broken bone, or severely burnt skin that our body is not able to heal by itself? Biomaterials made of natural or synthetic substances can be used to support our body while it heals larger wounds. Now, our lab has made biomaterials for bone and cartilage repair. Biomaterials have been around for centuries. In fact, the Mayans used the outer layer of oyster shells to replace broken teeth. But it's only recently that the field has grown exponentially, and now we can make biomaterials for almost any application, for broken bones, nerves, muscles, even a broken heart, although not literally. Now, okay, so we can even heal a broken heart, but there's a small problem with that. Now, we have biomaterials. What happens when we implant them into our body? Remember the police force, the immune cells that I mentioned in my first slide? They don't recognize this big external material that's just been implanted into our body, so right after they encounter it, they launch a massive attack to try and get rid of it. Now, the immune cells don't know what we do, that the biomaterial is extremely important for proper repair. So, how do we educate the cells? In my research, I have found that just by controlling the stiffness of a material, we can change the immune response. While materials that are too soft or too stiff can make the cells go into attack mode, the right stiffness can make the cells accept the material. I also found that by adding proteins and sugar-like molecules, no, not from the sugar club, it can make the biomaterial more liked by the immune cells. Think of it like bribing the police with donuts so that they don't come after you. So I hope I've convinced you that my research will eventually lead to the development of biomaterials that are safer, faster healing, and more accepted by our body for successfully treating large injuries. Thank you.